There's an idiom about seeing a sausage being made, that it's a disgusting, horrific process that will put you off this once-loved final product. So with that in mind, let's look at how an exam paper gets from here to here and demystify the process a little bit. Let's start with a comparison, an A-level exam. So if you've gone through the UK and specifically the English system, this should be familiar to you. If not, it might have some resemblance to your experience. So the first thing you have to notice about this paper is that it's very rigidly typeset. The questions are clearly boxed out. There's a space for your answer. You'll also see things like barcodes and other warnings to not write outside the boxes. And this is because in the modern day, pandemic conditions accepted, these papers are scanned into a national database and marked online. Previously, they would have been packaged up, sent to the markers, and they'd be marked and scribbled on while they sat and watched EastEnders or whatever people did in the 90s. In the digital version, they are scanned in, automatically cropped, and the marker just sees the question they want to answer. It's a very quick and efficient way of getting thousands of these things graded relatively quickly. And speaking of the markers, the mark schemes for these are extremely rigorous. They contain a very comprehensive list of things that count as answers, that do not count as answers, and what counts as a serious error, which will award you 0 marks for the whole question. For instance, very notably in chemistry, you must refer to ions and not charged atoms, even though the difference is, well, no one's going to misunderstand you in the real world over that one, but the mark scheme says it, so it must be true. The strictness of these schemes means that anyone being paid to mark an A-level paper must be trained, and they must prove themselves on specimen answers first and agree perfectly with the question setters before they're allowed access to the real thing. This all means that, and I will choose my words very carefully here, these marks are highly reproducible. If 2 people in completely different environments, schools and areas of the country submit the same answer, they will get the same grade, even if the person marking it is different. There are a few other things you might notice at first. Each question is comparatively short, usually formatted to have maybe 1 sentence per paragraph. They're designed in a way that provides scaffolding or removes it, depending on the level of difficulty the question is pitched at. There's also a complete absence of question marks. Each question is instead governed by a particular command, things like deduce, calculate, justify, and so on. And the exam board responsible for the paper provides a list of those and the expectations associated with each word. So if you are doing A-level exams, make sure you've looked those up. So with that all in mind, let's look at a higher education paper instead. The usual caveat here is that this is my experience and within chemistry. So I've produced exam papers in 2 institutions and a light-touch online exam in a 3rd. I've also talked with people all over the country and have access to external examiners from many other departments. So while the details are specific to me, I know that the broad process is the same in most UK universities and science departments. So the main difference between an A-level and university exam is that we write these questions. These are not centralised. They are not set by a separate body. The actual person delivering the course to you as a student, or the one physically standing in front of you, is the one that has written these questions. This is why actually turning up and talking to your lecturers is a really good thing. They're not going to tell you what the questions on each paper are going to be. That would certainly be unfair misconduct. But they will say, this bit is important, and they will start to nod their head and look serious, and that's probably a hint that it will make an appearance on the paper. Also, make sure you turn up to the last lecture or 2, because by then the exam is likely approved and final, and anything they've forgotten will probably get a mention then. So if a lecturer in the last session says something like, oh, this is an important bit of apparently random information, just take the hint. When it comes to sitting the exam, the first thing you'll notice is that the questions are on a sheet like this, all nicely formatted with instructions, and you write your answers separately on its own booklet. Actually, I don't have a blank one because getting hold of blank answer booklets happens to be pretty hard. That's intentional for anti-fraud reasons. You shouldn't take any spares out of the exam hall either. You need to be aware of this in advance if you're used to A-level style exams, because it means you are responsible for putting the relevant information into these blank answer booklets and making sure it's legible and laid out correctly. You don't need to copy each question down word for word, but you do need to be clear about what number the question is and which subpart. That also means you don't get an indication of how long your answer needs to be. But that's your judgment to make. Usually the questions are shorter than you might expect. Basically, just take a look at how specimen answers are written on past papers that you have access to. You should normally have access to at least 1 year's worth of papers and answers. You're usually asked to answer each question in a separate answer booklet, and you need to write your name and student number on each one. The reason behind that is that these booklets are separated and sent to markers individually, and those markers will also be the ones who set the questions. So I'll be writing and marking question 1, someone else will be writing and marking question 2, someone else will be marking question 3, and so on. It seems like a bit of a waste of paper, but it's the most efficient way of turning this around when you could potentially have 100, 200 scripts to go through. We then collate them together and they're second marked by someone else who also has written questions for the paper. Usually the rules around that differ, but conventionally about 10% or some minimum threshold will be spot checked and marked by a second person. Now, one thing about higher education exams is that there's usually an element of choice involved. This is very different to the A-level paper where you must answer every question. It is a nice thing to have because the course content can be huge and maybe you don't get it all, and maybe you know the qualitative work but you hate the calculations. So, okay, you get that in the exam as an option. Maybe you hate spectroscopy but like quantum mechanics. This paper will let you choose between them. There are a few ways of putting that choice in, but the most common setup we use is to make 3 parts of a question, A, B, and C, and say that A is compulsory, and then you can either answer B or C, or variants of some sort on that theme. In those cases, it's important not to answer all 3 components, either accidentally or because you think it'll get you more marks. The standard policy is usually to only mark the first thing we see. In that previous system about answering B or C, if you answer A, B, and then C, you're only getting marks for A and B. Even if you got 2 out of 10 for B and 9 out of 10 for C, that's fairly standard policy. Sucks if it happens to you, but that is the standard, so read the instructions. It is absolutely vital that you read the paper thoroughly before you begin. You need to understand what choices are available, what you want to answer, and you need to know that before you start. So the very first thing you need to do with this is read it from beginning to end. Maybe do a little asterisk next to questions you think you want to focus on. Take 5 minutes if you want to do this. Take 10 minutes, 10 if you want. You will not regret spending that time. The questions you encounter will also usually be a little bit more flexible in terms of their possible answers than one seen at school level. And this is for 2 reasons. One, we're working at an intellectually higher level, at least in principle. We're usually assessing more flexible problem solving. You may encounter molecules that were not in the lecture course at all, because the aim isn't for you to memorize those examples, but to spot, say, common functional groups and know how they react. You may see kinetics equations that aren't the basic first and second order ones because you just need to describe what information it tells you. You may also be asked to bring in examples from your own reading. This is much more common in finalist years, but you should be warned about that in advance. So if you're told to, make sure you go to the library, do the reading, and have those examples ready to use. The other reason is that we can be more flexible in marking because we're not having to mark hundreds of pupils to a national robust standard. Maybe we're marking as few as 4 or 5 master's level questions or a few dozen first year questions. We have the time and scope to look at the context of someone's answer and come to some judgment on it. There can be a lot more partial credit available for reasonable attempts than at school level because of that. So if you get an answer in a calculation wrong, there are a lot more marks available if it's also well laid out and we can see where the error is. On the other hand, if you've written absolutely impenetrable garbage and we can't make sense of your method, and it's also clear that the final number is way out, well, it's not going to be worth anything. If you know an answer is wrong because you calculate a bond length of several kilometers, it happens a lot. Comment it. It's more important that you can self-analyze those answers and sense check them than to blindly chug and plug values into a calculator. That's a really common mistake as well. Okay, so how did these things come to exist? The process of building an exam usually happens just before the start of term. We're preparing courses, we know roughly what we're going to teach, we know what sort of questions we want to ask, so it might just end up in a notepad file somewhere in a draft form. Now, the first official step is to get those questions reviewed by the chemistry section. So we have inorganic, organic, physical, and analytical sections who review each other's questions. Other universities may do this on a module-by-module basis or by differently named sections. At this meeting, everyone reads the questions and checks the answers. At that point, we're checking if the question is the right level of difficulty, if the right information is provided, or even if it's actually answerable. It takes the best part of a day to go through it, with a few pairs of eyes on it from the start. And a lot of errors do creep in and get picked up at this point. Someone might have changed a molecule halfway through a question because they're rewriting a question that's 5 to 6 years old. We also check whether questions are allocated into parts correctly. So a common change at this stage is to take a large blocky paragraph and ask that it gets split up to like part 1, part 2, part 3, etc. Requests like this ought to make sure we're very transparent with where marks are coming from, especially in first or second year exams. We really want multiple parts that are clearly 3 marks, 2 marks, 3 marks, 2 marks, rather than one complicated question that's worth 10, and for it to be unambiguous where all those marks come from. At finalist level, now that sometimes reverses. We might see more complicated questions with more complex problem solving or more applied knowledge, and those might be worth 10, 12, even 20 marks each. And a common discussion to have at this stage is whether that big finalist question contains enough information to give you the right expectation, or too much information so that people are just guided through it. But the revision process will usually clarify all these expectations we have for anyone taking the exam. We're not here to trick people into getting low marks. If anything, very much the opposite. For us, after that, it's seen again at a department level. Any relevant program directors, head of sections, etc. look over it. And at that point, we're checking for length, problem solving, making sure it's formatted correctly and unambiguously. Even minor things like making sure superscript negative numbers are clear and making sure that chloride Cl can't be mistaken for carbon and iodide Ci because of the font. Again, that's another day's work to go through everything. The final check is the external independent examiners. They're academics from all the universities who get access to the papers. They also get access to the marks and the answer sheets when we're done with them too. They're checking that we're following the process correctly, and they bring us up any failures to second mark properly, for instance. Usually they'll comment on things that may be non-standard or whether terminology is properly accessible to people. Very, very occasionally they'll request major revisions because it turns out the question can't be answered. Or something's accidentally ended up garbled in the last round of revision, something like that. We have to log any changes that they request and implement them, or give a very, very good reason for why we're going to ignore them. So the whole thing is very robustly looked at, yet errors can still creep in. There may be multiple ways of responding to a question that the question setter didn't consider. There may be a typo that leaves things ambiguous and that somehow we didn't catch it. And what happens in that case is, well, we can change things. We have control. And that's the big change from A-level and schools to universities. Or we can change anything up to any point. It's part of the academic freedom that we have to make judgments about students' abilities, and therefore we can self-correct for any errors or problems that we introduced ourselves. It's rare in a process like ours, which produces a lot of revisions and improvements, but it still happens in most universities. If you're sat there wondering if the exam has a colossal error in it that makes it impossible to answer, well, we'll become aware of it pretty quickly. You won't get 0 marks because of it. We'll just let you know how we've decided to fix it. The most common one, to be fair, is just that the marks don't add up correctly, in which case we just scale things or adjust because we think it asks for too much from people in a short time frame. The weirdest one is that the wrong paper was once issued. It was a repeat of the previous year due to an admin cock-up, in which case you just discuss the best course of action and base it on the results. We do try to be transparent there. Again, this is academic freedom. This is the advantage of taking exams at university. We have the ability to make on-the-fly adjustments to things and to judge people on their merits. So the important thing is not to be scared of these things. We put a lot of work into them. We're here to make sure you can show us your best work through them too.